Okay, this is part 2 of chapter 1.1 maximum and minimum values. Before we even begin the examples in the textbook itself, what I want to actually cover is some ideas of the maximum and minimum point. So for example, these are my own examples. If I have this equation over here, I've completed the square. So I will not go through the process of completing the square in this case. If I complete the square in this case, x minus 3 square minus 6. So what I have here is this. If you look at this form over here, you will notice that x minus 3 square is always greater than or equals to 0. Any value you put in here, the lowest value you can get is 0, and then it will increase to a positive number. So the smallest is 0 equals to a positive number. From here, if I subtract 6 minus 6 on both sides of my inequality, the direction doesn't change. Hence, right, I'll say that x minus 3 square minus 6 is always greater than or equals to negative 6. So I can actually make this statement here. Hence, okay, x square minus 6x plus 3 is always greater than or equals to negative 6. So it means that the lowest value that this graph can go is negative 6. So I say that this is a minimum value with negative 6. So how, if I were to represent this on the Cartesian plane, what I get is a quadratic graph. So that's why here is a smiley face where x squared is positive, hence it's smiley. You will notice that if I draw the graph, my minimum value of y is negative 6. And it occurs when my x value is 3. How do I get this 3 value? You look from here. We have to make this x minus 3 square equals to 0. So I will say that x minus 3 is equal to 0. My x value itself is equals to 3. So the minimum value occurs at 3, negative 6. So these are just some ideas for you to think about as we go through this chapter. Okay, I give you another example now. My example here, these are my own examples. X squared minus 2x plus 9. What I've done here is I've completed the square. I've written it in the completed square form. So again, what I'll say is this. X minus 1 square will always be greater than or equals to 0. I've explained the logic there. Hence, x minus 1 square plus 8 will be greater than or equals to 8. So it means that it implies that x squared minus 2x plus 9, okay, why? This and this, they are equivalent values. X squared minus 2x plus 9 is always greater than or equals to 8. So once again, this graph will have a minimum value. So the minimum value is equals to 8. So if you look at this graph itself, you notice that if I were to draw the graph, you can use a graph sketching software. But if not, you will see that actually for this graph, the lowest y value can go for is 8. And it occurs at my x value of 1. If you don't believe me, use any graph software to draw this for you. So how do I get this value of 1 here? Just to observe, it actually comes from this x minus 1 square. So my intent is to make this portion of the completed square form equals to 0. So I say x minus 1, I equate it to 0. My x value is 1. So it means that my minimum value of y is 8 when my x value is equals to 1. Okay, next thing here is another one of my examples. I have done completing the square here. Okay, notice that now the coefficient of x squared is actually negative. So when you complete the square, be very careful here. Not to worry, I will give you an example in example 3 where the coefficient of x squared is actually a negative number. So if I were to complete the square in this case, what I'll get is the completed square form. So what I can do here is this. If I start, I will say that x plus 3 square is always greater than or equals to 0. However, if I were to multiply by negative 1 on the left hand side and negative 1 on the right hand side, multiplying or dividing by a negative number will lead to a change in the direction of the inequality sign. Hence, negative x plus 3 square is lesser than or equals to 0. If I add 5 to both sides of my inequality, what I get is this over here. So this value now, it is different from slide 1 and slide 2. Now you notice that the value of the function is less than or equals to 5. So I can make this statement. Hence, okay, negative x squared minus 6x minus 4 is always lesser than or equals to 5. What this implies is that there's a maximum value because it must be 5 or less. Hence, the maximum value is equals to 5. If I were to represent it on the Cartesian plane, what I get here is this. You will get a frowny graph. How do I know that the graph is frowny? Okay, because the coefficient of x squared is negative. So it's a frowny graph. And if you were to use a graphing software, hey, lo and behold, it is a maximum value. And the maximum value occurs when the y value is equals to 5. Now, how do I get my x value here of negative 3? So maximum value is 5 when my x value is negative 3. Again, just like what I did in the previous slide 1 and slide 2, just take the x plus 3. Okay, just take what's inside the bracket. You take x plus 3 is equals to 0. It comes from here. My x value is equals to negative 3. Hence, the maximum value of 5 occurs when my x value is minus 3 or negative 3 rather. Last example, again I have this graph. What I do is express it in my completed square form. I will go a bit more quickly for this one. I will start with x minus 4 square is greater than or equal to 0. Negative x minus 4 square, don't forget to change the direction of inequality, will be lesser than or equals to 0. If I subtract 5 from both sides of my inequality, I get this inequality here. So, hence, okay, I can state that negative x squared plus 8x minus 21, okay, these two values are equivalent. This is lesser than or equals to negative 5. So, negative 5 is the greatest value and it can only be less than negative 5 from there. Hence, this is a maximum value. So the maximum value is equals to negative 5. So again, how do I get, if I were to draw this out on a graph, my max value is negative 5 and it occurs when my x value is 4. Where do I get my x value equals to 4? X minus 4 is equals to 0. My x value itself is equals to 4. Okay? I will go on to slide number 5 now. Okay, for slide number 5, what we will have here is this. What I am going to do is part A first. So in part A, you will to express the following functions in the form ax minus h squared plus k. What this implies is that we have to express this into the completed square form. So, if I want to express this in a completed square form, be very careful. Before you can even do completing the square, the coefficient of x squared must be equals to 1. So in this case, hey, there's an issue here. The coefficient of x squared is equals to 3. So what I need to do is to factorize 3 first. So from this expression, I have factorized 3. So I'll get x squared minus 2x plus 2/3. This is equivalent to this. Now I start to do completing the square. What I do is 3. Okay, I open the big brackets. I will say x minus 1 square minus 1 plus 2/3. I close my brackets. If I simplify, what I'll get is 3. Okay, here will give me negative 1/3. So, if I were to open up my brackets, see, when I open up my brackets, what happens here is the 3 will multiply to this term, and the 3 will multiply to this term as well. So, what I'll get is, the function is 3x minus 1 square minus 1. Okay, please be careful here. there is no way for you to multiply this 3 into this bracket here, so just leave it as it is. Alright, so now what I can make, the statement I can make is this: x minus 1 squared will always be greater than or equals to 0. If I multiply by 3 on both sides, 3 times x minus 1 squared will still be greater than or equals to 0. Multiplying by a positive number on both sides of the inequality does not change the direction of the inequality. Then I subtract 1 from both sides of my inequality. What I get is this. So this implies that, hence, okay, fx, okay, so this function, this expression here is equal to this, is equal to what we had right from the very start, okay, and this is equals to fx. So here I can say that hence fx is greater than or equals to -1. So that means that for this function there is a minimum point, because -1 is the lowest value and it goes up, the value just increases from there. So the statement I can make is this has a minimum value of -1. Okay, now I'm going to do part B. Okay, remember I said that there will be points in time whereby the coefficient of x squared will actually be negative. So as in this question here, notice that the coefficient of x squared is -2. The only way they can start to complete the square is by allowing, okay, the coefficient of x squared to be equals to 1. So what I can do here is I factorize -2 from these 3 terms. So I've done in my first step there, I factorize -2. Then next what I can do is this, I will start to complete the square. So what I get is this minus 9/16 minus 3/2. Okay, I've just completed the square for what was inside the brackets. So my function is equals to -2, okay, x plus 3/4 square. So if I simplify everything, I will get plus 33/8. Okay, now how am I going to work this out? How am I going to justify my answer? I know, okay, I've already drawn the diagram here that is a maximum point, but what I can do is this. For me to explain my answer, again, we start with x plus 3/4 square. This is always greater than or equals to 0. -2, x plus 3/4 square. Multiplying by -2 on both sides of my inequality will lead to a change in the direction of my inequality. 0 times -2 is still 0, by the way. Okay, then negative x plus 3/4 square. If I add 33/8 on my left hand side, I will also add 33/8 to my right hand side as well. Now, what happens here is this. I will say that hence, okay, my function will always be lesser than or equals to 33/8. So that means the maximum value is 33/8, and then the function just decreases in value from there. So this is actually a maximum value. And the maximum value is equals to 33/8, or 4 and 1/8 if you want to write it out. Okay, for 4 and 1/8, and then where is my x value? If they do ask for the x value, my x value is -3/4. How I get -3/4? It comes from this bracket here. X plus 3/4 is equals to 0. My x value is -3/4. Okay, time for you to pause the video and actually to go and try 3. I will show you the answers in a few moments. Okay, and now we're going to proceed in 3, 2, 1. Let's go. Okay, I factorized. In order for me to complete the square, my coefficient of x squared must be 1. So I factorized 2 from all the terms. I've completed the square. So what I have gotten here is this. Actually, I missed out some working. So let me do the additional working. x minus 3/4 square is greater than or equals to 0. 2 times x minus 3/4 square is greater than or equals to 0. Then 2 times x minus 3/4 square or minus 17/8 greater than negative 17/8. That means the function, the minimum value is negative 17/8, and the function, right, will be greater than negative 17/8. So therefore, this function has a minimum value, and the minimum value is negative 17/8. Just for you to try to understand and put things together, I've also added in the sketch of the graph over here. Okay, for 3b, I won't explain as much. I factorized out negative 3 from all the terms. I've completed the square, and I've gotten this value here. So I think I missed out the working again. So I will say this: negative 3 x minus 2/3 square will always be lesser than or equals to 0. Negative 3 x minus 2/3 square will be, will be minus 2/3 will be lesser than or equals to negative 2/3. Hence, fx will always be lesser than or equals to negative 2/3. So that means fx, the function, has a maximum value of negative 2/3. To make better sense of it, I've actually sketched the graph for you on the side of the slide over here. Okay, I'm going to move on to example 4 now. Okay, for example 4, they asked to show that x squared minus 2x plus 6 is greater than or equals to 5 for all real values of x. So what I have done here is this: from what we have learned the past few slides, I've actually done, okay, the completing the square. So this expression, I've completed the square, I've reached this. So same logic that we'll be doing again and again. Since x minus 1 square is greater than or equals to 0, then it implies that x minus 1 square plus 5 is greater than equals to 5 for all real values of x. Hence, okay, this term, this expression is equivalent to this expression. Hence, I can make the statement that x squared minus 2x plus 6 is greater than or equals to 5 for all real values of x. Okay, try it 4 is over here. Please do try. Before you do need to complete the square here. Do not forget to factorize negative 1. If not, you will not be able to complete the square. Okay, this is my answer for try 4. So I factorized negative 1. I've done the completing the square inside here. So I multiplied my negative symbol back. So I'll get this. Again, I start with negative x plus 2 square is lesser than 0. You subtract 6 from both sides of the inequality. I know that this is lesser than negative 6. So implies that negative x squared minus 4x minus 10 is lesser than or equals to negative 6. So the question actually didn't ask you to prove that this is lesser than or equals to negative 6, but I asked you to show that this is negative. However, this expression is lesser than or equals to negative 6. So if it's lesser than negative or equals to negative 6, it must be lesser than or equals to lesser than 0 itself. Hence, this expression is negative for all real values of x. And that's it for today's video. Thank you for